For today's lesson, we're going to learn about how to calculate angles. But first, we have to go over some background. You already learned about complementary angles. These are angles that add up to 90 degrees. When you put them together, they form a right angle. And you can identify that there's a right angle because you will see a small square put in the vertex for the two. For supplementary angles, those are angles that add up to 180 degrees. When you put these together, they form a straight line angle or a straight line. So we're going to talk about intersections of lines. So when you have lines that intersect at one point, forms a series of angles. So we're going to take a look at what type of relationship they have to one another. First type are vertical angles. So angles that are on opposite sides of the same vertex. Here we have a vertex of C. The ones that are on the opposite sides of each other, the angles, are called vertical angles. So vertical angles are congruent. Okay, and congruent is just a fancier word to say that they equal each other. So in the diagram, we have angle DCF and GCE. Okay, they are on opposite sides of the vertex. Therefore, they are vertical angles, and they equal each other. In addition to those, we also have angle DCG and FCE. Those are also vertical angles. Now, following the rule, if they're congruent or equal to each other, we can say angle A is equal to angle B, and we set up the equation. We also see that angle DCF is equal to angle GCE, and DCG is equal to FCE. The other types of angles that are formed are called adjacent angles. And you kind of already learned about these. So adjacent angles are angles that share a common vertex, again, but they're next to each other. Okay, and that's what the word adjacent means. It just means that they're next to each other. So in order to calculate adjacent angles, you have to have some type of known measure for them to be combined. Okay? So in the diagram here, we have the larger angle BAD. That's the entire angle here. Okay? That is equal to the interior angles. We have BAC and CAD. So again, our calculations, our equations, are going to be angle A plus angle B equals angle C. And then using the other notation, we have BAC plus CAD equals BAD. Now, speaking of known measures, you guys already learned about some of these. So the first type is complementary pairs. So again, we have that right angle, so we know they add up to 90 degrees. So in this case, we have angle A plus angle B. When we set them up in an equation, those equal 90 degrees. So we add those together, and that's going to equal 90 degrees. Similarly, for supplementary angles, we see angle A and angle B. When we add them together, that's going to equal 180 degrees. Again, it forms a straight line. So now, what happens when we start to have unknown variables in our angles? So we're going to have to use algebra in geometry. So for using algebra in geometry, you're essentially solving for the unknown. So when you're calculating angles or solving for variables, you have to set up the equations using information about the angles that you know. So the first type would be vertical angles. And vertical angles are congruent. So when you set up the equation, you're going to set them equal to each other. Adjacent angles have to be combined in order to calculate. Now, for complementary angles, that's a type of adjacent angle. When you add those up, they're going to equal 90 degrees. For supplementary angles, you're going to add those up, and it's going to equal 180 degrees. So let's try a few examples. Example number 1, we want to solve for x in the diagram. So we see we have two lines. They have a vertex. On this side, we have 40 degrees. And now on the opposite side, we have 12x minus 8 degrees. So we can see that these are vertical. They're opposite. So that also tells us they're congruent. So since they are congruent, we know they equal each other. So now we can set up an equation. And again, we're going to say that they equal each other. So this angle, which is 40 degrees, equals this angle, which is 12x minus 8. From here, we have to solve the two-step equation for x. Now we've done this in the past, but you have to get used to it again. Okay? So we're going to add 8 to each side. Those cancel out, and we have 48 equals 12x. We divide by 12 on both sides. Those cancel out. 48 divided by 12, and we get x equals 4. In the next example, we have a different diagram, still solving for x. Now we have a clue. We see these are adjacent, and we see another really important clue, which is right in here. We see that they form a right angle. So the two angles form a right angle because we see the square. And that tells us they're complementary. And since they're complementary, we know they add up to 90 degrees. So we can set up this equation. Again, we add the two angles. We add 3x and 45, and that's going to equal 90. Again, we're going to solve the two-step equation for x. We subtract 45 on both sides. And I have 3x equals 45. Divide by 3. And I have x equals 15. In the next example, we see something, again, we're familiar with. We see that these two angles, when they're lined up, they form a straight line. So because they form a straight line angle, and they form a straight line, tells us they are supplementary. Again, supplementary, we know they add up to 180 degrees. So we can set up the equation. This angle, 110 degrees, plus this angle, 7x, equals 180. Again, solving two-step equation. We're left with 7x equals 70. Divide by 7. And x equals 10. Now, something a little bit more challenging, not too bad though. We're going to solve for x in the diagram. We see we have a clue. We have a right angle. But we also notice that we have 2 terms that include x. Don't do anything differently. We still follow the same process. Okay? We still have a right angle. We still know that they're complementary. We know they add up to 90 degrees. And even though x appears in both angles in the pair, we set up the equation the same way. So we take our first angle, x minus 20. To that, we add x, and that equals the 90 degrees, since they're complementary. Now, the way that we have to solve, obviously, that's slightly different. This is a little bit more than a two-step equation. It is a multi-step. So because it's a multi-step, we have to first combine like terms. So combining like terms, we get 2x minus 20 equals 90. And then, again, solving for x, we get x equals 55. Now the last one. This one's definitely tricky. This is considered a higher order thinking or hot problem. These are the type you really have to pay attention to what's being asked for. So in this diagram, we have someone playing racquetball, and the racquetball has a deflection with the angles shown. The question is to find the measure of A. Now I know because this is kind of small, might be a little tough for you to see, but there's A right in there. Okay? So the angle that we're looking for is this one right in here. So we have to go with what we know first. So there are 3 angles. Let's count them off. We have 1, 2, 3 angles. And they make up a straight line angle. In this case, the wall. So because they form a straight line angle, they are supplementary, and the 3 angles add up to 180 degrees. So the first thing we need to do is solve for x. Can't have too many unknowns. So we have to get rid of the one unknown first, which is x. Again, setting up the equation, we take our 3 angles, add those together, we combine like terms, we solve the 2-step equation, and we get x equals 20. But that's not it. That's not our answer. The problem asked us to find the measure of angle A. One more time. A is, let me clear this out so you guys can see it better. A is this angle right here. So the angle is 3x plus 1 degrees. Now, since we solved for x, we can substitute in the value of x into this expression and then solve for the angle A. So angle A equals 3 times the 20 that we found for x plus 1, which equals 61 degrees. So again, for all of our high order thinking problems, you're going to solve in a similar fashion, but as always, you need to pay attention to what is asked for.